Hi everybody, welcome back. Today we're going to be discussing the skeletal system. So the skeletal system, quick review of the functions of the skeletal system. So this is very active tissue. A lot of people think that once you make your bones, that's it, you're done. But actually the skeletal system is constantly remaking itself. Every 10 years you will have recreated your entire skeletal system. So the obvious functions of the skeletal system would be support and protection. Again, the skeletal system provides that strong support so that you can stand up and you're not just a mass of tissue laying on the ground. And it also helps to protect your more delicate, important organs. For example, the cranium protects the brain, the vertebral column protects the spinal cord, and the rib cage protects the lungs and the heart. But the skeletal system also provides a place for muscles to attach. We all know that muscles contract, and in doing so, they move the body. But if they didn't have anything to pull on, such as the bones, then we really wouldn't be moving much at all. A couple of less obvious functions of the skeletal system would be at the bottom here, the last three. So hematopoiesis. So remember, poiesis is formation, and hema means blood. And in fact, hematopoiesis is the formation of blood cells. And this happens within the skeletal system in the red bone marrow. We also have energy storage. Energy storage happens because we can store fat in the yellow bone marrow. So when the red bone marrow isn't being completely used for formation of blood cells, so for example, as we age, we don't make as many blood cells anymore, that turns to yellow bone marrow, and that's where we store fat. And really the last thing that the skeletal system does is the storage of minerals. So we store different types of minerals there, for example, calcium. When we need calcium, we take it from the skeletal system. When we have plenty of calcium, we store it up for another day if we might need it in the future. So it kind of becomes a mineral bank for the body. There are a couple different types of bone, and they are classified by shape. You can see examples of them here. So the first type of bone is the long bone, and this is obviously a bone that's longer than it is wide. This example is the femur. A short bone is going to be sort of squarish. It's going to be about as wide as it is long. This particular example is one of the tarsal bones in the feet, make up the ankle. A flat bone is going to be kind of a sandwich type of bone that we'll look at in more detail in a little bit here. This particular piece of bone is a piece of the cranium. An irregular bone is one that really doesn't fit either long, short, or flat. The example given here is a vertebrae. It's kind of got projections coming off in lots of different directions. A sesamoid bone is the last one, and that's the patella that they're showing us. And that's a special kind of short bone that's completely embedded within connective tissue. In the human body, we have about 206 bones. And the reason we say about is because some people might have a few more, some people might have a few less due to anatomical variations. The skeleton itself is not completely ossified until about age 25. The last bone to become completely ossified is the proximal epiphysis of the clavicle. So to look at the gross structure of a long bone, we're looking at the humerus right here. And the first part of the humerus we're going to look at is the epiphysis. There's two epiphyses. These are the expanded areas of bone at the top and the bottom of the bone. So one of them is going to be proximal, meaning closer to the point of origin, and one of them is going to be distal. So we have the proximal and distal epiphysis. The long, narrow middle part of the bone, or the shaft of the bone, is called the diaphysis, and you can see that here. The metaphysis, you can see the top one here, or the proximal one here, is an area of bone that holds together the epiphysis and the diaphysis. You're going to have one on the proximal part of the bone and one on the distal part of the bone. We also have articular cartilage, which is hyaline cartilage, which provides a nice, smooth, friction-free surface between areas that articulate with other bones. Here's an example up here, which covers the head of the humerus. We also have articular cartilage on the distal end of the humerus, where the trochlea articulates with the trochlear notch. The periosteum is made out of dense, irregular connective tissue. There's actually two layers to it. There's an outer fibrous layer and an inner osteogenic layer. And this is going to contain the osteoblasts that will make new bone on the outer part of the diaphysis. You can see the periosteum is a piece of connective tissue that's pulled back away from the surface of the bone in this picture. The medullary cavity is a hollow cavity on the inside of the diaphysis. This is the cavity that contains space for blood vessels and nerves to run through the middle of the bone. The inner connective tissue that covers and lines the medullary cavity is called the endosteum. You can see a piece of it is pulled back in this picture. The inside of the medullary cavity is lined with the endosteum, and inside the medullary cavity is where the yellow bone marrow is stored. Red bone marrow in an adult is primarily found in the epiphysis or in the flat bones. Remember, red bone marrow is hematopoietic material. It's responsible for making new blood cells. And yellow bone marrow is for the storage of fat. The epiphyseal plate in growing children turns into the epiphyseal line in adults. In children, the epiphyseal plate is the area between the epiphysis and the metaphysis where the hyaline cartilage is proliferating and causing the bone to grow longer. When we talk about bone, there are specialized cells that actually create the matrix of bone. These cells develop from an osteoprogenitor cell. You can see that this starts with osteo. Anytime you see osteo, think bone. This osteoprogenitor cell will start to do the work of secreting the matrix, and at this point in its life it's called an osteoblast. The osteoblast will continue to secrete matrix until it has walled itself off into a little cave called a lacuna. At this point the cell is considered mature and it is called an osteocyte. Its job is to maintain and survey the bone tissue in case it needs to change to meet the needs of the body. However, if the bone needs to be broken down, either to harvest the minerals stored in the matrix or to remodel the bone for some other reason, a cell called an osteoclast will do that work. It does this by secreting enzymes that dissolve the matrix of the bone. You can remember the functions of the two types of immature cells in this manner. Osteoblasts build bone. Osteoclasts crush bone. Let's see this in action.
Bone is a dynamic tissue that is continually being built, broken down, and rebuilt in a process called bone remodeling. Bone tissue is broken down and resorbed by multinucleated cells known as osteoclasts. These cells are derived from monocytes which originate within bone marrow. Osteoclasts play an important role in liberating minerals and other molecules stored within the bone matrix. Bone tissue serves as a repository for vital minerals including calcium phosphate and various biologically active molecules, such as growth factors. The release of calcium from the bone can play a role in maintaining its homeostasis within the body. The cells responsible for building new bone tissue are known as osteoblasts. Osteoblasts are thought to be derived from cells found to be associated with blood vessels. Once active, they start to produce the organic component of bone, osteoid, which is predominantly made of collagen. Minerals start to crystallize around the collagen scaffold to form hydroxyapatite, the major inorganic constituent of bone, which contains calcium phosphate. Bone mineral density, or BMD, can be used to estimate the strength of bone and to assess the risk of fracture. As osteoblasts form new bone tissue, many become embedded within the matrix and differentiate into osteocytes. The structure, composition, and cellular processes that occur within bone allow it to simultaneously serve as a calcium reservoir. while providing structural support for the vital organs and for locomotion.
Remember that bone is connective tissue, and that the definition of connective tissue is living cells in a non-living matrix. We just discussed the cells. Osteoblasts secrete the matrix, osteoclasts break down the matrix, and osteocytes maintain the matrix. But what is this matrix? In the case of bone, the matrix is made up of collagen fibers plus crystallized mineral salts. The most important mineral we're talking about here is calcium. Osteocytes build bone by initiating calcification. Calcium phosphate plus calcium hydroxide react to become something called hydroxyapatite. If you combine hydroxyapatite with calcium carbonate and some other minerals and collagen fibers, that becomes the matrix of bone. What vitamin do we need to absorb calcium? If you said vitamin D, you are correct. Do you recall where we get vitamin D? Vitamin D is added to milk, which happens to contain calcium. But if you recall from the Integumentary System chapter, one of the functions of your skin is to utilize UV light to create active vitamin D. There are two types of bone, and most bone is made up of a combination of both of these types. Compact bone is found in the outer part of the long bones, and the top and the bottom of the flat bones. On the top picture is showing a transverse section through a long bone, and the area in the bottom is showing a transverse section of a flat bone. You can see that in both places, the compact bone looks very smooth and dense. The microscopic anatomy of compact bone contains osteons. The other type of bone is spongy bone. Spongy bone is characterized by the presence of trabeculae and is found on the inside of both flat and long bones. You can see here that the trabeculae are little projections of bone tissue that make the bone look like a sponge. This not only lightens the weight of the bone, but it also makes room for blood vessels and nerves to run through the inner part. Flat bones have a sandwich of compact bone on the top and the bottom and spongy bone on the inside. Let's take a look at the microscopic structure of compact bone. The main structure of compact bone is the osteon. This is the hollow circular structure that gives bone its characteristic tree trunk ring appearance. The center of the osteon is the central canal, a hollow space where blood vessels and nerves run lengthwise through the osteon. Each ring of the tree trunk is called a lamella. There are a couple different kinds of lamella. This arrow shows concentric lamella, the rings that form around the central canal of the osteon and make it look like a tree trunk. Because these structures are circular, there's some space between the edges of two adjacent osteons. Those spaces are filled with interstitial lamella. The third type of lamella are the rings that form around the periphery of the entire bone, and these are called circumferential lamella. You can see in the magnified picture to the side the little osteocyte in its cave. The cave is called the lacuna. There are also a couple of types of canals that run in a perpendicular fashion to the osteon. The largest of these are called the perforating canals, and they carry blood vessels from the central canal of one osteon to the central canal of another osteon. Much smaller are the tiny openings where the osteocyte projections connect one osteocyte with another osteocyte in a different lamella. These are called canaliculi. You can see that there are a lot of blood vessels running through and within the bone. This connective tissue is very well vascularized, which allows it to heal quickly from breaks. It makes sense that there is such a good blood supply, as we need to be able to deposit minerals and then remove them to respond to the changing needs of the body. Spongy bone does not form osteons. Instead, it is made up of branching projections of bone called trabeculae. A transverse section of the trabeculae is shown here, and you can see that the trabeculae does contain lamella, lacuna, and canaliculi. That's it for today. See you in class.